thing that we need to point out about clustering is that it is called unsupervised learning because we allow our algorithm to go and learn which objects are similar to each other and combine them together on its own. We're not giving it any examples of how to do that. We're just telling it, compute the distance, if these are similar, put them together, if they're close, put them together, if they're far, put them in another group. That is very different from what we did with decision trees and with classification. So clustering analysis is unsupervised learning. Algorithm, which is different from classification because in classification we created this classifier and we use parts of the data to train the classifier and learn which objects are of which class. So we gave the classes to the algorithm and we showed it how the objects look like from a specific class. And then we train the classifier like that. So the classifier is learning from example. And when it's learned or trained, we can use the rest of the data or the test data to test it on data it has not seen before and ask it to predict the class. That's called classification. So that's different from clustering because in clustering we never gave it a class. We never gave it an example. We just tell it, go on your own and learn which objects are similar without telling it what class or group they belong to. So cluster analysis is not classification, it is not segmentation, which segmentation we will just go and divide the space into pieces. Let's say dividing students into groups by their last name. Results of query, give me objects that have such and such property, or group them in some external specification. Query is not clustering, and also partitioning of graph is not clustering. So, now, the first example we've seen on the first picture was very clear. There were three clear groups of objects that were close to each other. It's not always like this in real life. Once we plot some data set into space, it might end up looking like that. Just us looking at it, can you tell now how many clusters are here? On this picture?
2.
Somebody might say 2 because it's one group here and one group here. Any other opinions? 2. Somebody saying 4 or 6?
What if you have clusters of clusters?
They could be overlapping. So the first idea was there were 2 clusters, this one and that one. But there could be 6. So these objects, 1 cluster, 2, 3, 4, 5, and 6. Or they could be 4. Say these objects are together and these objects are together. That would depend on the algorithm that we choose, on the number of attributes that we have, and the types of attributes we have, and the distance measure that we choose. So all of these things make a difference about the number of clusters and the type of clusters we we produce. So whether we have done good job pre-processing the data and choosing the best distance measure, and the algorithm that we use might produce different results from another clustering algorithm. So there are two types of clustering algorithms that we have. We have hierarchical and partitioning algorithms. So the first one is called partitioning. In the partitioning clustering, we will divide the objects into non-overlapping clusters. If we do that, each object will belong to exactly one cluster. So partitioning clustering basically partitions the space into pieces or clusters. These objects right here could be separated into two clusters that are non-overlapping. And if they're non-overlapping, each point belongs to precisely one cluster. These objects were combined all together into one cluster. Now, when we do hierarchical clustering, we have a little bit different situation. Because in the hierarchical clustering, we allow the clusters to overlap. So with hierarchical, what we do is a set of nested clusters is organized as hierarchical tree. This is how it looks like. So if these are the original data points, point 1, 2, 3, and 4, hierarchical clustering, first we will calculate the distance from each point to every other point, and then we will combine the 2 points that are closest to each other together. Next, these points together are considered as one cluster. And we need to calculate the distance from that newly formed cluster to the rest of the points, and whichever one is closest to it, you merge them. So now these three are now merged into one cluster. And finally, the last one will be merged, and now they're all merged. And we have a dendrogram. The dendrogram would show which ones were merged first, and next which one was added to them, and next which one was added to them, and at what distance. So this was the first distance. Let's say that distance 1. This is the second distance, that's distance 2. And the third distance is distance 3. Why would we want to merge all the points together? What is the purpose of that? So we are trying to find clusters, groups of similar objects, but in the end, as we can see in this algorithm, all of them end up in one big cluster. So the idea here is that we will merge them all, but that's not the end of the result. That's not the end result. We will create this dendrogram that shows us at which distance they were merged. And if we see some huge difference in the distance, we're gonna say, wait a minute, this new cluster is very far now from our current cluster, and maybe we should stop here and keep those separated. So we're going to go back into our dendrogram and analyze the distances and decide